This is the pre-introduction to the Digital Investigator course, and what we're going to do is cover a few basic terms in here. So don't worry too much if you don't understand all the concepts involved, but really we want to just understand some of the terms that are used, some of the abstraction that goes on inside the internet. But our focus generally within this course is to understand network traffic and to be able to investigate the sources of that. So the key things that we'll look at are some basic terms that are used on the internet and with networking. We'll look at how computers are arranged into networks with some topologies. Then we'll look at some of the key technologies used to make local area networks, and then onto wide area networks. And then we'll try and abstract out the network protocols that are involved and some of the devices such as switches and routers and firewalls and so on that are used on the internet. And then in the end we'll look at a basic networking infrastructure and some of the key things that are used to allow two computers to talk to each other. Okay, so normally what we have is we have two users, and the two users want to communicate between each other. So we have two hosts that are involved, and we want to send data from one machine to the other. Okay, so we have some data here, and we'll find out later how that data is segmented up and what the protocols it uses to be able to send the data over reliably. But we have some data, and then the data can only really be sent over the line one bit at a time because we only have one wire that we're sending over. So we serialize and send the data out one bit at a time, and this is defined as a bit stream between the two devices, between the network connections. The speed at which we send the bits through is often known as the network bandwidth, or the maximum potential for the bits to be sent through, and that is defined in megabits per second. So a typical network connection in an office might give us 100 million megabits per second, or 100 megabits per second. So it's 100 million bits can be sent over the line every single second. The higher this value, the more bits that we can actually send over the line. So we can even get gigabit links. 1 gigabit is 1 billion bits per second. And in some links with inside corporate networks, we might even get 10 gigabits per second. A network card that connects to a network, a normal network, will typically be running about 100 megabits per second. And when we talk about the way that bits are organized within inside the computer, we often talk about 8 bits together, and 8 bits equals 1 byte. So we can define our bandwidth in terms of bits per second, but we can also define it in terms of bytes per second too. But the normal method that we use is bits per second. So the network bandwidth really defines the actual potential to send data. But really, if we share the network with others and so on, we actually measure the actual throughput, which is less than the network bandwidth. And often the more users that might use a network, the slower it might become. So the network bandwidth really just gives us our potential to be able to communicate. For example, in a home network, we might have a wireless bandwidth of 54 megabits per second. But if we do a throughput test, we actually find that this could be less than 10 megabits per second, say. But the more the potential for the bandwidth, the more the throughput is likely to be. And the ways that we can communicate with inside a network is what's called Simplex. Simplex is really data just goes the one way from one machine to another. It doesn't go back. We can have Duplex on a network where we can send at one time and then we can receive at another time. So really Duplex is sending one way at a time. But in most networks what we have is that we have the ability to be able to send and receive at the same time, and this is known as full duplex. The different types of networks that we have are local area networks. These typically connect with inside a building. We can have wide area networks, and these normally interconnect between two local area networks, such as between campuses. And then we can have more metropolitan area networks, which span across cities, and are normally high bandwidth connections between them. So let's look at some topologies and how computers are organized into networks. Okay, so if we have a whole bunch of computers such as these, there can be many ways that we can interconnect these computers, such as with point-to-point. So the good thing with point-to-point is that we have a guaranteed connection, guaranteed bandwidth. It's fairly secure, as the media between them isn't really shared. But the disadvantages is obviously it requires more cabling, and it's not really scalable. The two main methods that we use is often what's called a bus type technology, and with this all the computers connect onto a single line, and then we can just interconnect between the computers. The other type that we have is what's called a ring type technology, and with this we make a ring around which the data can actually be transmitted. Good thing with a bus network is fairly easy to cable. The big downside is that it's a shared media, and our nodes must contend to get onto the network. With a ring type network, all the computers get a chance to share access to the network, but unfortunately if we have a break in the ring, then it can bring the whole ring down. The most popular type of connection within a corporate type network is what's known as star. With star, we have a central hub or a central point, and nodes connect into that point, and then it's up to the central device to be able to switch the data between the computers. And this gives us the concept of a network switch. With this we have a unit, and computers connect to it, and then it's up to the switch to be able to switch the data between the computers or out onto the network. A switch allows for multiple connections at any one time, and there is no concept of contention as we have within a bus network. The other type of infrastructure that we can have is a mesh network. With a mesh networks, all the computers are connected into each other. The problem with this is that the more computers that we have, or the more hosts, the more connections that we actually have, and it gets extremely complicated. What we can do though is that we can have what's called a partial mesh. In this case, we don't have to have all the connections between the hosts, but we can have some key ones. So in this case, if one of the links goes down, then the other links can actually take the network traffic. So if this computer talks to this computer and this link goes down, then there is still a route to go through from another one. Again, if this route and this route goes down, then there is still a route to be made from there to there. Within the internet, this is the type of infrastructure that we have, in that we can have multiple routes between two different nodes, so that if one goes down, then there's still the opportunity for the data to travel through another path. So let's look at one of the most popular types of connections onto networks, and that's with a local area network or a LAN. The most popular networking technology to create a LAN is what's called Ethernet, and Ethernet provides us with many standards such as that are equivalent to wireless communications. Originally, Ethernet was created with a bus type system where we connected onto the cable onto a bus, and all the nodes competed to get onto the network. So it used a technology called carrier sense multiple access collision detection. So any node that wanted to transmit would transmit, such as A transmitting and then B transmitting, and then each of the nodes would detect that there had been a collision with both of them talking at the same time, and then they would send out a jamming signal for the whole network and no one could communicate. Then one of the nodes would get back onto the network. The problem with this type of network is that it's based on contention of the nodes. Typical cables that were used were coaxial type cables. So this is a coaxial cable here. We have a sheath to protect the radiation coming out of the cable, and we have an inner copper core here. And we typically got about 10 megabits per second from these types of coaxial. Thick coaxial is a larger, thicker cable. Thin coaxial is the small cable. And we could see the range was between 185 and 500 meters. Then we got the concept of a hub, and a hub allowed you to connect the hosts onto a unit, and then inside it would actually create the network bus. With a hub, the other nodes can actually listen to the node that's actually transmitting at any time. So this could be used in wiretapping where node A is transmitting, and A can actually listen to the communications on the line. Again, the problem with this type of network is that it's a contentious network and nodes must compete to get onto the network. More commonly, what we have is a network switch. With a network switch, the switch itself determines which nodes are communicating or which ports are communicating, and then will switch the data. In this way, we can multiply up the bandwidth in that we can have multiple connections at any one time. And typical cables that we use are these twisted pair cables here. We can see each pair is actually twisted together, and that reduces the radiation that comes from each of the cables. And then we can get them shielded. So this is unshielded twisted pair here that we have. Shielded twisted pair actually has a foil around each of the cables, and that reduces the radiation from the cable also. We can also get fiber cable, and with fiber cable we get optical fibers which can transmit over a larger range and also have a higher bandwidth. So eventually we've got to connect all the networks up together, so we get the concept of a wide area network. And the key focus for a wide area network is that it interconnects these local area networks, usually with high speed connections. Okay, so we might have our Ethernet technology providing our local area networks. We might also have remote connections such as with wireless, dial-up, GSM and so on. But we really need a wireless, a wide area network to be able to interconnect. And so the typical methods used here are what are called ATM, cell switched connections. We can have packet switch or frame relay networks. Circuit switched is ISDN, T1E1, which are similar to the types of connections which are used in telephone type networks. We can also have lease lines. These are known as HDLC, PPP or SLIP. And the key for this is to really produce the interconnection between the networks. So let's look at how our networks are organized in terms of the protocols that are used and the devices. We'll be going into more detail later on in the program to be able to look at this, but let's have a quick overview of what the protocols look like and what some of the devices are. So what we have at the top is that we have some form of application protocol So it really relates to what it is we're actually doing. So if we're connecting to the internet, then we communicate with a web server, and we might use the HTTP protocol to be able to do that. The HTTP protocol allows us to send messages, to ask for pages, and to get it back in some sort of way that our web browser can understand. We might have a remote connection with another computer, so we might use the telnet protocol to be able to create a remote connection onto a machine. Or we might be transferring files onto another machine. In this case, we would use the FTP file transfer protocol. So these are what are known as application layer protocols. So we would typically look for the type of protocol that we're interested in. If it was email, we'd look for the email protocol, file transfer, FTP, telnet, and so on. Below that, we need to be able to create some sort of reliable mechanism to be able to get our data across the network. What we normally do is we normally create what are called data packets, and data packets are small chunks of data that are then sent over the network. They can find their own route over the network, but then arrive back at the host. When they arrive back at the host, they're reassembled back into the data, into our application layer protocol. As we'll find, TCP and IP are the most common of the two protocols used to create the network connection and to create the routes for the networks, for the network packets, and also to be able to create a reliable mechanism of sending the data packets over the network. And this is TCP/IP, and it really provides the core of the internet. Okay, we'll find IP is used for network addressing, and TCP is used for the segmentation of the data and to be able to chop it into these packets and then build them all back up into the data. And then below that, we use our devices to be able to get the data from one place to the next. As we'll find, we don't really need to know that much about the other device, typically maybe its network address, to be able to send data over the network, over interconnected networks. So we use things like switches and routers and firewalls and IDS to be able to create our network connections. And the great thing about the internet is that we switch our computer on, and straight away it can be seen by all other machines on the internet, or we can also see every other machine which is connected to the internet. And then we've got our cable infrastructure underneath and our communication connections, and then we might use some testing tools. As we'll see, ICMP is a typical tool to be able to debug that our networks are working. So this shows just a very basic infrastructure of how our network might look in terms of two computers connecting over interconnected networks. Okay, so let's so over here we see Bob is connecting to a switch. The switch, then this is a router here, and over here we have a firewall. So a firewall protects us from traffic that's coming in that might be malicious. So the firewall can block that. It can also block connections going out. If we don't want someone to access something on the internet, we might block it through the firewall. Okay, so we have our interconnected cloud here, our internet. Then on another side we might also have a firewall. And there we have a router here. The router allows us to be able to find the routes, the optimal route to go from one place to the next. In this case we can see we've got 3 connections on our router, and this creates what's called a DMZ, a demilitarized zone. And with a demilitarized zone we can actually place our electronic equipment, our servers, in a place that would allow access from outside. Probably what we don't want is we don't want people getting into our network, so we would block that through this router or this firewall here. And this is our DMZ, and here we see we've got some servers here. There's email, FTP, as we'll see, proxy, web, and so on. And again over here, Alice connects to a switch. And this is the way that the switch allows us to be able to add a machine onto a network. The routers, as we'll find, are able to communicate with each other and set up routes, so that Bob can connect to Alice if required, or Bob can send an email here and find that email server. We can also see there's other things. This is what's called an intrusion detection system. Intrusion detection system listens to the network traffic, and if it picks off something, it can create a log of it or create an alert. And we'll see that a bit later on inside the training course. These are some of the symbols that you might actually see. So this is a Cisco router, Cisco switch. This is what's called a NAT device, as we'll see in a little minute. There's a Cisco PIX, a firewall. There's a Cisco ASA firewall, and this is an intrusion detection system. Okay, so you'll see many types of symbols, but these are often used to represent the key network components. So now let's look at something a bit more real. We'll look at how a data packet can go from one computer to another. Okay, so here's our basic infrastructure. We're connecting onto a switch, and that switch eventually goes to a router. These routers all interconnect, and then we have a switch on the other end. So what we want to be able to do is for Bob to be able to communicate with Alice and use this whole infrastructure. So each computer on the internet has a physical address and also a network address. On the internet, these network addresses are used to route the data between these intermediate devices, where when we get to the very end of the network connection, this part in here, then it's the physical address along with the network address which is actually used to deliver the data. So the physical address is only actually required for the last part, the first part and the last part of the journey. As we'll see, when the data travels over the network, the physical address of the data packet as it travels, or the data frame, will actually change as it goes through the network, but the network addresses never change. So we have both a physical address and a network address. And if we just look on every computer, we could have multiple network addresses. So in this case, we can see here that for my wireless network, then my IP address or my network address is this one here. If I want to find out my physical address, as we'll find out a little bit later, I can use another command called ipconfig/all, and in this case I can now get more details of what my physical address is, and this should be a unique address on my network, and that is defined as what's called a MAC address, an immediate access code address, and this gives me my physical address for my machine. Each of these can be spoofed at any time, but it's easier to spoof the network address than it is to spoof the MAC address. But you should never take the physical address as a definite identification of a host. It's fairly easy for someone to change their MAC address to be someone else's MAC address. So let's say that Alice has just turned her computer on. So it would be probably very difficult for Bob to remember every single IP address that he connects to, and probably Alice has moved her computer or might have changed the network card. So normally we need an easy way to be able to find her, and we bring in the concept of a domain name. So domain name is an easy way for us to be able to connect to another device, such as a web server or so on. So in this case we now need what's called a name server to be able to map the domain name onto an IP address. So again, we'll cover this in a later unit, but we normally use DNS lookup to be able to determine what the IP address is. So whenever we access a website such as cisco.com, our browser does a lookup, finds out what the IP address, and then uses that IP address to be able to connect with the remote device. Okay, so the name server is another key important principle that we have inside the internet. Okay, so that's provided us with a very basic introduction to the internet. Now the key concept that we have is that we have the concept of what's called network address translation. So as we'll find out, the IP addresses can be mapped into a common infrastructure called the internet, and we give it a capital I for internet because it's a real thing. So these addresses are controlled and allocated. So if you want to connect to the internet, then you need a public address, and if you want to route between these intermediate devices, then they route with public addresses. It would be difficult for us to be able to get public addresses for all our computers that we might want to connect. The basic fact is that we've actually run out of IP addresses, IPv4 addresses, so there are no more to go around. So we need some way to be able to allocate host with an IP address. So we use what's called private addresses, and the advantage with a private address is that no one can really connect to us because we don't really have a public address unless we want to. So we create what are called private address spaces. So if you connect from home, there's a very good chance if you're connecting over a wireless network, you have a private address, and everyone is allocated an address inside your network, which is private, and then you have one device, typically your wireless router, that will be able to connect onto the internet and allocate a public address. So it's a very important principle, and often it's very difficult to see the information that happens behind this NAT because it's private. Many companies use it for security protection, and that they can hide who's accessing it because all that's seen from outside is a single IP address whenever they look at the logs. Okay, so that's provided us with some basic concepts. We'll be looking at these in more detail in the rest of the module.